Hello. Sorry about the wait. I had to get some stuff handled earlier today, but let's get into it. Oh, I got a notification that Gasadelen, I never know how to pronounce that. Sorry if I mangle it. Resubscribed. Thank you. And hello, Nemesis C. Glad you could join me. So, I've totally forgotten what I was doing last time. I think we were going to try and simplify some of these conditions. And also I need to learn how to use Qt because I have a scroll bar right here that should let me scroll to the side. What are we doing? We are writing a decompiler for Binary Ninja. So this nice pretty view you see right here is what we've been writing, as opposed to having graph view. And it's based on the medium level IL. But I've got these really long conditions here, and I'm pretty sure this condition isn't even necessary. I think that if we go to the disassembly graph for this function, everything comes into this function. So I'm not sure. So we got to figure out how to identify that the reaching condition is all of these blocks. And if it's everything, then it should just be like its own region, I guess. Maybe. But yeah, I've got to figure that out. So let's go back to, oops. And I think there's also some other issues that I've got to try and remember. Yeah, like we've got these ridiculously huge conditions as well now. I guess the first thing we can do today is try to simplify those. Can't really guarantee that I can actually get them into the decompiler today, because that might be some work. Oh, there's also the if-else thing that I was having issues with. So let's go ahead and remove the merge if-else thing first. If I can find that. I need to simplify this a bit. So if it's probably Binge's fault for the scroll bar, how do I fix it? Because probably isn't giving a correct size hint. Okay, so then since I'm in subclassing it, maybe I can fix that somehow. I guess I'd have to calculate the size of the longest line or something based on the tokens in the font. Okay, so I want to use condition visitor, I believe. So, okay, so simplify, that's what I did. I did a simplify, and I call that, and I pass in the condition that gets passed into the visitor. So if we go over here, oops. No, MLST. Once we do the regions, now let's do and convert region to condition. I can do it there. Oh yeah, I can explain my visitor stuff. Let me get it started and I'll kind of show. That is like my bread and butter. I'll have to pull up the BNIL visitor thing. Yeah, it walks the IL for a particular instruction, sort of, but it can also move between multiple ones depending on, you really control that yourself. Yeah, the main class is actually pretty simple. I want to see if this at least works first, and then I'll talk about it. Did I need to pass anything into that? Yes. No, I don't. And then let's see if this gives me anything. No, it doesn't. It breaks. Cool. Oh. Var type width. My bad. Okay, that one didn't output anything. Oh, okay. Also failing. Okay, then I'll take some time to, oh, did I get any? Oh, that's interesting. Oh, I must not be managing those. Okay, so the BNIL visitor class is really simple, and of course Visual Studio is not going to give me the definition. This is it. It's literally just this, and what this does is when you call visit on an IL instruction, because IL instructions are tree-based, I use this mostly to recursively visit the different expressions that are in a IL instruction. So you come into it, and the first thing it does is it checks the operation of the expression. For example, if we come into here and we look at like MIL10 operation, that one's going to be a set bar, I believe. Yeah. So it takes the name of that, and it appends it to visit. And then it checks to see if the class has a method that's implemented for visit MLIL set var. And if it does, then it passes that expression to that class. Otherwise, it just kind of logs debug and says like, hey, I didn't have anything for this one. And then returns none. And so generally you can just check for none when you are looking for something that's unimportant, just to check. So then coming into this particular visitor that I implement, then it inherits from that class, and all you have to do is then implement the methods for the various operations that you want to handle. And then, as you can see here, all I do then is say, well, I don't know what this operation is, so let's just visit it, and it'll automatically figure out what it is and then call the correct function to process that, and then I get back the result of that. And so in this case, we're building Z3 constraints using the MLIL. And so we are saying like, okay, get the left expression. Okay, that's probably like a variable or something. If it's a variable, then turn it into a bit vec. If it's a constant, then return the constant. And then combine those and return left compares or has to equal right. And then this will return the constraint that left is equal to right. So that's kind of what we're doing here. And in this particular case, I needed SLE, I think. Yeah. All right. And I implemented a visit both sides down there. You don't necessarily have to, I do this sometimes myself, that I'll add things that aren't actually IL instructions, just because it makes it easier. But like, if I show you another example, if we come back to the old stuff, the thing that I was doing for the deobfuscation stuff was also implemented on a BNIL visitor, and as well as a background task thread. So it's got some extra functions like run and stuff like that. But if you come down here and look at this, you'll notice this one actually visits multiple types of IL as well. You can do that because they all follow that dot operation tree-based thing. And so in some of the things like here, you can see that I actually convert, I take the medium level IL and I get the low level IL version of it and start checking some stuff. And I don't visit it there, but there's somewhere in here that I know I visit the low level IL version of the instruction. And then that's how it gets into some of these other ones. And I don't remember off the top of my head why I did that at the time, but I know it was like there was information that was lost between low level and medium level, and I needed the low level version of it. And so it made it nice to be able to seamlessly transition between the two in the same visitor class. Oh, that would probably be one of the reasons why it didn't output anything. All right, so I think it also had load that I needed to implement. Load, yeah. I don't know what I want to do about load. Let's just make a bit vec for it. And we'll call it load. And then this is going to be expression.size. Wait, no, times 8. Because I have to tell it how many bits. This is probably also wrong. Okay. And then I guess we can implement, actually let's just call this mem. I don't actually, I might have to go and like create an array and stuff. Actually, no, I won't have a store because it's all in conditions. So it's just load that I need. So that should be enough. That should be sufficient to create a bit vector that it will recognize. So let's see how that works. Oh, thanks for resubscribing. Say please, please. I'm sorry that you're not able to watch me. All right. That is not the one I wanted. Far field. I cannot remember what oh, actually, just do this. Source and offset. Actually, that one's just going to be okay. How do I represent this one? It doesn't say how. Okay, and then size is expression.size. Okay, and so then I can do a, because source is going to end up being a var. Actually, it is just a var. So I can do this. And then I can do, what is it? What's the thing in Z3 where you just take like a slice of it. I can't remember suddenly. Oh, the wiki. All right, give me. Not helping. Bit vectors. Give me a thing that tells me what the. Yes, there's the array. Ugh. All right. Just go look it up. Because I know I've used it before. Oops, not that one. Find Heartbleed is the one I want. Extract. That's what I want. Extract the high is offset plus size. It's going to be the bits, so that needs to be times 8. And then this one will be just offset plus 8. And then we put source here. We'll see how that works. I'm really confused why this one isn't giving me, because you should be making, should definitely be coming to convert. Well, I guess maybe it considers it all just one region. Sorts bitback 1 and bitback 8. Why is there a 1-bit? Did I miss a times 8 somewhere? D3 condition, expression expected. Did it get a none or something? Oh, yeah, probably. All right, where's a simple function that I've already implemented everything for? Okay, it seems like this one didn't do it either, but it should have. Because, like, that should have been simplified. All right. Are you just not getting into this function? You are not getting into that function. Okay. So we're not doing it here. It must be down in order regions then that it's happening. Yeah. God damn it. What are you getting back then? All right. Everything should be getting... All right. Nope. Wait, did it open to this function, or did I not quit? I must not have quit. Yeah. Okay. We're getting none back. Why are we getting none back? Because I'm dumb and didn't return anything from this. Alright, gotta force quit Binja. So there's something, I think there's something about the update checker that sometimes it gets stuck in a background task or something. There we go. How can I reorder these? I mean, not that it matters too much. Let's see. I want to see if this is just this, because if it's just that, then I can simplify that. Nope, it's a Z3 expression. So how do I get the... How do I get the true out of that? Is there like a value or something? Let me see. Do I ever check it to see if it's just... No, I just extract. Okay, so true and false can be used in Boolean expressions. So how can I check Let me see what the sort is on it. I think it's what, sort, like this. Trying to remember my bool. Okay. So they're all bool. How do I get a value out of it? What happens if I do a solve on this? There's a solve, right? Yeah. Okay. That doesn't seem to have done anything. So all right, I'm printing it in here too. Yeah, I don't want to print the non-simplified version. And I can put this back to return simplify. And solve doesn't seem to do anything for me. It also outputs something, so that's weird. Does simplified reach, does it have a value? Actually, let's do this. Just see what we got. It's gonna be nice and long. Oh. Yeah, not too long. R's, good ID. The console doesn't wrap very well either. Children, AST. Do I need to have a visitor for Z3 as well? I just want to know if it's true. Z3 bool value. Case is true. Is there an is true on there? I don't see anything. Oh, this is a bool, not a boolean. So what's the difference between a bool and a boolean? Is there one? E3 bool sort. This doesn't help. I don't want to read this. This is C++. I just want... Can I get an int val? Ugh, this is frustrating. Return the Boolean sort. Integer to Boolean. Now, why are none of these functions in... Are they like in Z3? Like bool val. Okay, I want is true. There we go. That is what I wanted. And that should just then give me a... Yes. False, false, true. Perfect. So then I can say if is true, simplified reaching condition, then reaching condition equals none. And that should turn this into just a haha! Yay! So now we don't have that thing here. Now, how do I easily show that two things are identical conditions? I think I have to oops. Why do I have a wonder if it's the sorts bitback 1 and bitback 8. So it's comparison of equality that's causing an issue. All right, let's do this. Let's just do a print. So at least tell us which one we're actually checking. Oh, because I did offset plus 8, not offset times 8. Okay, so I need to do -1 on this. Yeah. U greater than. Signed greater than. I really should just implement all these, but I'm lazy. And I could probably also simplify this a little bit too, so I'm not doing every single one of them. And this should be less than or equal to. Hey, actually got it. All right, so it doesn't simplify that. So I've got to figure out how to figure out how to do this such that that's a weird one. Why is it 3? How did it even get a 3? It should be a 0 or an 8. gosh. Oh. It simplified it by... Wow, that's really interesting. Because it's an unsigned greater than, it simplified it by saying, okay, well, 7 is the bottom 3 bits. So if, as long as the upper 3 bits, or upper 28 bits or whatever, are equal to 0, then it's equivalent. Wow. I guess that's simplifying it. Okay. So now I need to figure out how to turn that into... I really want to figure this one out. Because that is... Because everything from the switch statement comes here. So what can I do to figure that out? Because, so I know it's like, it's branch dependence. If I come here and check this. But I don't know if that... So its branch dependence is only this one and this one. I feel like I should be taking branch dependence into account at some point, because I was earlier, and that's where it kind of took into account, where I wasn't taking into other things into account, so it was messing things up. But when I was using branch dependence, this one came up as just being in a sequence after this. I wonder if... Let me see. If I do I have an MLIL or something in here? Self has it, right? Yeah, self function. No, that's not where I wanted to go. That's also not where I wanted to go. Fuck, I lost it. Right here, okay. I'm putting it in the wrong one. The one up here. Still got something going. Reaching condition. Oh. Oh, I know what I can do. I can say db.start. Yeah, I don't know how well that works for UI-based stuff. Okay, so false. True, true. False, false. Okay, so 1E. So that's this. Ugh, 1E is like 30, right? All right. And 2F is probably 47. But it's saying that the branch dependence isn't there? Yeah. Seems like it would have... Oh, it's not start. It's end. Oops, end -1. Okay, so we still have a false there. All of these are true. Okay, so I think I can say if the branch dependence does not contain this basic block end, then it should be a sequence. Let's see how that works out. Okay, that still looks correct. All right. We got rid of that big if condition. I like that. That looks a little bit better. Now, let's see. What do my loops look like? Oops. Got an ad. Oh, because of the load. And I'll have to handle shift right and everything as well. It works for now because it turned the load into a mem none. Huh, okay. So now what should we do? All right, this one's broken. What do we got? Greater than or equal to. Got a really big one right there too. That one looks like it's probably also a yeah. All right. $13. Nothing. Okay. I feel like I did this once before, where I said if it had no branch dependence, and then it like completely broke. No dots. Function. Let's try that. Okay, that gets me my return down there. Anything else look weird? This one doesn't have a return. Oh, I guess it only will return from there. Is that the only return? Explode bomb. Return, okay. It just got pulled into the loop. That's fine. This is starting to actually kind of be cool. All right. Now, what's the AST for Z3 look like? Because I want to be able to pull out yeah, no, right? It's already like pretty decent, it seems. I don't know if it'll be as good as IDA because I'm not moving it all the way up to like C pseudocode. I mean, eventually I'd like to do some optimizations and stuff on it, but all right. All right, so ooh, it's got a value. That doesn't help me. That's just an address of something. What do you do with the AST object then? Okay. What else is there on here? Nothing. What's decal? Okay. So that tells me what the thing is. So let's see. All right, so what's this look like? Okay, so that's the operation. And then those are the two children. Yep. Okay. So I wonder if I can replace things in C3 modify AST. Oh, this is not what I want. An AST rewriter. Python AST rewriter. That's pretty funny. Okay, that doesn't help me. I am flying by the seat of my pants right now. Nope, that's not what I want. And that's the Python AST. I mean, I could also just like rebuild it myself, I guess. So if I do a and that's going to have a decl name of war. If I want to take one of those out, then I would do oops. Now what if I do condition 6 equals or condition 1 or condition 2 condition 3. Whoops, that wasn't what I wanted. Yeah, okay. So then if I wanted to do something if I wanted to get rid of one of those, I would do condition 6 children 0 condition 6 children 1 children 1. Nope. Cool, so I can extract it like that. So if I find a... So the reason why I'm looking at this is because one of the things that I have to do for simplification, if I can get back to my Chrome window, one of the things they do is where is it? Oh, C and R. Similarly, nodes belonging to the false branch have reaching conditions of the form not C and R. So refinement step chooses a condition C and divides children nodes into 3 groups: true branch candidates VC, false branch candidates V not C, and remaining nodes. If the true branch and false branch candidates contain more than 2 nodes, we create a condition node VC for C with children VC and V not C, whose conditions are replaced by terms R. Obviously, the second term of logical AND expression, C or not C, is implied by the conditional node. So it becomes if R, and then inside that we do the if V, else V not C. I believe that is what we do. So I think they do that. Yeah, and so in the case that it's just if C and if not C, then R is just true. So then they don't make a conditional for it. They just make the if else, which is what this is right here, B1 and B2. If and then else. So then the question is how do we Conditions that we use in this refinement are chosen as follows. We first check for pairs of code nodes that satisfy condition with a letter that a region header, okay. This must be reaching condition of the opposite of this reaching condition. So these conditions correspond to if then else constructs and thus are given priority. When no such pairs can be found, we traverse all nodes in topological order, including conditional nodes, and check if nodes can be structured by the reaching condition of the currently visited node. Okay, so we start at the top. That's what they're doing here. They're saying, okay, what's the reaching condition for this? If the reaching condition of that equals the opposite of this reaching condition, then structure that as an if else. So I think what I can do, I'm gonna blow away this entire merge if else bullshit that I broke. Where is it? Get the fuck out. All right. Step 1. Look at the top level nodes and see if C equals not C. I don't need to sort them now because Actually, are they sorted? I guess sort of they are. And then let's do it again. Actually, let's call this what did they call it? I and J. HI and I and HJ and J. Could probably do this with a product. Let's see. If hi equals hj, continue. So then the next thing we need to do, say C in I equals self dot reaching condition, generate reaching condition. Should really cache these reaching conditions. Do I do anything like that? I don't. I'm probably making a million of these. Oh well. C and I is none. Continue. All right. So then here, let's do the simplification. C and I simple. What is it? Is there an equivalent? Okay, so I think is EQ will give me what I want. If it's an equality expression, oh. That's not what I want. I want is is maybe is true will work. If is true, C and I simple equals not C and J simple. Need not. Then that means that we can turn this into an if else. Let's just do that for now before we start modifying a bunch of stuff. Did I get one? Nope. Did you not go in here? You did. Okay, cool. You are definitely okay. Checking more than once. Oh, it's the condition is outputting something. Yeah. Get rid of that and maybe it'll make it a little easier. Okay. But it's not printing this, so maybe I just need to put simplify? There we go. Okay. So that means that we should make an if else. Let's make a new function. Actually, this is probably a node. Actually, no, it's a read. Fuck. At this point, yeah, they're nodes. I should make my regions inherit from medium level ILST. All right, so we've got these. Let's take a condition. I may have to convert these conditions to BZ3 expressions at some point. And just parse those. So in I is going to be this should be a condition node. Because it has a reaching condition. And I believe this one will also be condition node. I think I want to make a medium level IL. And then here, no, make a sequence node that is j.header, and then no. I've done this. I did this before, and I probably shouldn't have deleted all of my else stuff earlier because that. No, I don't remember how I was doing this. So Let's go look at the else node. Right. And I believe, actually, now if I remember correctly, the if statement condition, yeah. True is going to be a sequence node, so all I have to do is pass in this. Actually, I could just do this. And then self.regions j.header. I think we delete that. I think that does it. Let's see what happens with that. Nope. Left off something. Don't need that. Don't know why I did. Dictionary change size. Oh, right. Cannot do that. No. Let's just do a list here. This shouldn't be a large list. There shouldn't be that many regions. Just want to see if that actually fixes it. Well, that completely got rid of it. Where did it go? And I should have still been there. Maybe that's not what I wanted. Let's pass HJ in just in case. Seems like it's her. Yes, it appears to have deleted all the regions. Oh, because it's doing it backwards. That is an issue. Okay. So we pop that, and then move J and J. And then we can delete it from here. I think a list can change size. Maybe we do a to remove. No, I don't need to do that. I can just move this out here. And then say J is not none, then let's try that. Hey, look at that. Damn it. That issue is back. All right, phase 4. This is 5. And this condition needs to be sorted based on its conditions index. Because the problem is that since this is true, it comes down here. Really, that should be a... Oh, it's because of the branch dependence thing. I bet this has no branch dependence. Yep. Fuck. So how do I figure out that this comes before this one? Could do something like... What have I been... So condition node... So nodes just depends there. And it just becomes a condition node. It's the top level condition nodes that are the issue. Those are the ones that get put in based on what their original header was from their region. And I can't change that. How do I tell? I wonder if I can do something where I get the instruction in. Oh, what function was that? Was that 4? Is 4? Yeah. Because that's a not, so that's going to be 15. Okay. I want that one to print out, so that's not where. I need the other place where it does reaching condition. Control end works in flow graphs now. That's cool. All right, instruction index 7, instruction index 11. I think either of those are the ones I want, though. I want 4. So what is happening here? Oh. Okay, here we go. What the hell is happening here? There's a little equals out there. Did it like go on a new line? Or did it just not print something out? I don't know. No, I think it just put it on a new line for some reason. That's weird. Okay. So here's where I want to pull this EAX not equal 1 and not EAX not equal 1 out so that it's just this. Except no, I don't want that because, okay, I can't do that because this is not, R is the not var 8 is greater than 0, and this one doesn't have R, so I can't actually simplify that. So that's a separate thing. So really, I just need to figure out how to say that this needs to go here. My ordering needs to be able to say that this does not have an edge between something from this region. So it's this. All right, because I'm popping them off of it. So I feel like I need to sort these differently. Because I don't think it should be in the region. Because it's a top level basic block. So this is a region and this is a region. And if I were doing depth first, traversing by, like that's what they're doing here. That's why it's numbered this way. They take all the true branches first. Come in here, come in here, come in here, and then here. But then this branch already, this node has already been visited, so. So then, normally I can use the instruction indices to identify the ordering of the regions. But in this case, and it's not dominated by either of these. No, I guess it is dominated by both. So then, oh no, 5, 7 is itself. So the only one that dominates it is the 0 through 5. So that doesn't help me. Post dominators are empty. So I don't want to. I don't want to bring it into that region because of the fact that it's got a reaching condition to the top thing. It really should be. It's like the last node that's checked before going into ordering the regions. Damn, this is a hard one. Like the only thing I can think of is to switch my regions dictionary to having a list and then having both of these be at the index of the condition, and then saying, okay, well, if they're both at that condition, then turn it into an if else. But I can't turn it into an if else because it needs to just be a fall through. From like an if here. Like maybe this should be a region. No, this should be a subregion under this, and then these two should be regions. And it then should just be if not. Oops. Should be, if we bring this up to right there, and then this one is just an else here. Because I've got this right here, and I've got this. So if I can just the reaching condition for that one is what's messing it up though. Because it could be an else here or an else here, but so how do I figure out that this should just fall through? What's the... I wonder if knowing the... if knowing this one will change anything. Oh. What? Oh. Ugh. Really? C is none. Yeah. So knowing there's a reaching condition between them. If there's a reaching condition between them, then the other one should be first. So how do I turn that into a key? There's a function for changing a key to a key. I don't actually know how the function works, but so let's try that. I don't know if this will go backwards or not. I think that's what I want. I'll do like that. Oops, did I just quit? No, I didn't. Okay, good. This may be backwards, so we'll see. Nope, that didn't even work. Okay, so it looks like that's backwards. So we want is not none. No, that doesn't seem to have fixed it. Is that not? No. All right. Oops, that's not going to do anything. Gotta make a format string. Oops. Ugh. All right, so instead, let's do this. I want to see. No, ugh. Okay, why does that not work? One of those should give me a sort. Okay. Okay, is comp to key just not working? Because this definitely... Oh, maybe comp should be returning... That probably was the problem. I probably just needed a -1 and a 1. Let's try it the other direction. Oh wait, no, I want to just do first equal true. Nope. Okay, it printed out. Oh wait, that's the reverse. So I want 1, -1. Okay. So it should be popping off the back. So let's take this and make this the comp to key. Haha! There we go. That's how you order things. You check to see if there's a reaching condition between them. If there's not a reaching condition, then the other one goes first. Now, is that going to be an issue somewhere else too? I'm not sure. All right, that looks a lot better. We have our outs there. We have our outs there. This one still works. That one is broken because I haven't implemented ULE. I'll get all these done eventually. Wonder why those are different colors. It's weird. Yeah, still got a lot to do here. This one looks really complicated. Looks like this one's working as well. Got the outs. I gotta come in here and do these. Is there? Whoop. There's no attribute header. Okay, there's something there I have to figure out. Oops. I don't know what's going on with there. Hello. Let's see what that one looks like. Yeah, that one seems to be. So this is like, we are building a decompiler for Binary Ninja. Whoops. Got an exception. What did I do wrong? Oh, none type. Oh, 279. I don't even need that. So let's see. That was what, phase 3? Let's see if that works now. Well, that's looking better. Yeah, this is one of those things I want to optimize out. Like, if I have which I think will involve kind of doing a pass over the SSA form, where I check and see, okay, because like I named these two different things. Whoops, there's that flow graph crash. Really wish they would fix that. I know they're gonna have to fix it before see, it's always this. Oh no, that's a different one. Get basic block source. All right, I'm gonna keep this one. I think that's, oh, well, I might have reported that one before, and it was going to be a very complicated process to fix. See if I can, okay. But yeah, so you see, they're the same thing. Actually, no, they're two different things. It didn't rename this one for some reason. That's interesting. Usually it does that. Let's see what that looks like in the disassembly. Oh no, let's look at the SSA form. Yeah, they're the same thing for some reason. Normally, excuse me. Oh, maybe they're not. This one stayed named the same. Oh, I had named something int too. That's why it changed the name. Okay, so yes. So anyway, so like in a particular case like this, where it's int2 equals int1, Binary Ninja is a reverse engineering platform. It's a disassembler, as well as a bunch of analysis built on top of the disassembler. And so we're building a decompiler, which takes the disassembly part and turns it back into something that looks more like C code. So yeah, when it's something like this, where it's just like this equals this and it doesn't actually do anything with it, I actually want to I can check that in the SSA form and say, okay, if this is not doing anything else, if it's just set to this and then just reused without doing anything else to it, then just optimize it out and just say use int1 instead. And just get rid of that line completely. That would be something I would like to do. But that's in the future when I can get through some of these control flow things a little bit more. Also need to clean up types a little bit here. I think this doesn't really, the medium level IL isn't cleaning this up as nicely as I would like it to. But let's see. Yeah. I like how you can change stuff. So that's looking pretty good. And it looks like it's about time for me to finish up for today because it's 6 p.m. now. So next up, I think we'll apply the if-else thing that we did to more of the nodes. So instead of just doing the top regions, we'll next step into those regions and look at their top level conditions and see if we can do any simplifications there, like quick simplifications. And then we'll step into those, like we'll do the whole topological thing that they were talking about in the white paper. And then once we've gotten all of those simple if-elses, then we'll start looking at doing the C and R and the not C and R ones and see if we can turn those into if-elses and then put them up under the R condition. And then we can go back to fixing loops and like turning those loops into do-whiles and for loops and all of that great stuff. I think that'll be really cool. I'm just gonna get rid of this huge commented thing while I'm thinking about it. What about after loops? After loops, I am not sure. I will either do more, try to optimize some stuff, try the rest of the owl. If I do that, then yeah, I would do some of that optimization stuff I was just talking about. Otherwise, I will call it quits on this project because I don't want it to run too long because I'm already on like my 10th episode of writing a decompiler. And I think eventually people will get tired of it, so I'll have to find something else to do. So then, yeah, I'll just like throw it up on my GitHub and other people can like play with it and stuff like that as well. And maybe fix some of the stupid things that I've done to get it to work. Yeah, I should probably push what I have already. It's been a while since I've pushed it up. So maybe I'll do that tonight at some point. Anyways, I need to get going. It's after 6. So thanks for watching, everyone. And hope you come hang out again next time, Tuesdays and Thursdays. Yeah, have a good night, everybody. Bye.